I'm presenting here the work that we've done on the eWaterCycle platform. I have to acknowledge the entire team behind that. This is a team effort. And I want to thank the organization for giving us this podium to share our work with you all. What I want to focus on today in the open science realm is we're all talking about open and fair. How hard is it to do that? And especially how hard is it to reproduce someone else's research? I have a bachelor student. She just graduated with her bachelor thesis in civil engineering. And I like to give my bachelor thesis the assignment, pick any river in the world, find out what a problem is for that particular river, do an analysis of climate change impact. And we do that as a bachelor thesis project. It's a 2-month, 8-week project that they need to do. And Tirsa van Esch, there's a more dramatic picture of Vienna during the floods last year, but that was copyrighted by AFP. I was not allowed to use it. Last year there was an immense flood in the Wien, the river where Vienna is named after. What you can see here very clear, just next to it, this is the channel that the Wien is channelized in downtown Vienna. Just next to it is subway line U4. And just a little bit more downstream, the water reached the level of that wall that protects it. And Tirsa wanted to know, how often does this happen currently? Does that comply with the design standards of that wall? Civil engineer after all. And she wanted to know, how often will this happen in the future under different climate scenarios? For that, of course, she needs a hydrological model. She needs to make a choice which hydrological model is best. I want to do a very quick quiz. If we publish hydrological models, we always have these kind of pictures in our papers. Which one is this? You're all hydrologists, you should know, you read these papers. This is not Vic. No. I have a list of names if you want to have a look. Which one is it? Yes, Lorraine knows because Lorraine is from the Netherlands, and this model is from the Netherlands because we're very siloed in which model gets used where. See the work by Dr. Lieke Melsa on the anthropology behind that. But this is Pisar Glob from Utrecht. Another one? HBV. Yes, this is HBV. This one? This is generated by chat. So if you ask it to make a schematic, I like how there's a, if you look over here, there's a whale hidden in the subsurface. So this is basically trained on all our schematics. What a non-human thinks that hydrological models look like. You laugh about this one, but you did not laugh about these. Half of these names are also generated by ChatGPT. So hydrogene over here, hydrological generalized estimation network emulator, doesn't exist. Maybe it doesn't exist yet. Final one. WFlow, because it's gonna come up in the session after this. I inserted this. I want to make a point here. How do you pick the right model? If you look at hydrologists, this is a Google image search for hydrologist. This is what Google thinks that we look like. I think most of us know by now that this is mostly what we do most of the time, right? I mean, if you're lucky, you get to spend 5 to 10% of your professional time in the field, which is, I mean, one of the beauties of hydrology is that we get to go into the field. But then we spend 90% of our time behind our desk making models about the data that we collected in the field, or that Earth observation data that we collected, that someone else collected for us. And then we basically encode all that knowledge in hydrological models. And these hydrological models get encoded in different programming languages. Reproducibility, hard to run someone else's model. But that model includes all that knowledge that was gathered in the field. And so we think that is a problem. And that's what we wanted to tackle with the eWaterCycle system. I was very happy to hear this morning that we already said it's about lowering barriers. Well, one of the barrier is to use each other's models and data. That's what we try to do with eWaterCycle. How we do that, bit of technical stuff. We have a Jupyter hub running somewhere. Anyone can install it on his own infra, but we also provide access to our infra, mainly if you're affiliated with the Dutch Academic Institute. We're running a Jupyter environment, and we hide the models in software containers, which means that we can talk to a Fortran model that has that snow model in there from a Jupyter environment in Python without having to engage with the Fortran code. It even means that we can have two models, one running in MATLAB, one running in Fortran, all interacting with that same Jupyter environment in Python without having to know either MATLAB or, well, we're doing Octave because we're doing open source, but without running either MATLAB or Fortran. So basically the gist of this is that we made a very clear separation between the models on one side as objects that are sort of immutable, I mean there's versions, etc. And then the experiment you want to do with the model on the other side. But for a lot of our experiments, you want to interfere with the model, even during runtime. You want to say, okay, every time step I'm doing a what if, change this value within the model. Every time step, couple this value to this value of this other model. So there needs to be an interface. We picked the BMI, worst acronym for an interface ever, but basic model interface is good because it's very basic and you can define it in all different programming languages. Of course, this only runs if you also have infrastructure, and I was happy that that was brought up this morning. Okay, this in its entirety is what we call the eWaterCycle platform. Going back here, how does that help my student? Well, she did this analysis, and I want to show you something. Demo. Ooh, go here, now go here. Oh, can you share the screen? Live demos, people, it's always a... Where's the share button on this one? Go. Ah, there it is. Perfect. Yeah, thank you. We are sharing. So, because it's Jupyter, it has, the Jupyter Notebook have both text and code in them. So this is our project page. We now have our bachelor theses here on our project page. This is the new generation of what a thesis should look like. This is her thesis. So she writes this as Markdown and Python. And if you go to the chapter 4, this is what I want to show you. In her thesis is the code that ran the analysis for her results. And this code generated this graph that shows that the return period of that one flood was about 1 in 800 years. It was designed for a 1 in 1,000, so it's a little bit less. And then she did future scenarios. Here's the code for it. Here's the output of the models. Here's the analysis for the statistics. And she could show that under climate scenarios, that 1 in 800 would move to a 1 in 200. Doing that on a Jupyter environment allowed her to immediately share that. Problem is, what if you want to build on this? This is just one climate model. What if the next student wants to do it with another climate model? The beauty of this is, yeah, I will accelerate, I know. You can immediately go to Jupyter Hub, and this will pull and do some magic in the background. It will immediately open up a runnable version of that notebook that you were just looking at, which means that you can now start changing this. You can build on it. You can even fork it and go to and then build on that science. So basically there we go. Share.
First one.
Yeah.
The first window. The
This one.
Yeah.
Go here. Yep. And then I go F5, whatever present is.
I think it's here.
There we go. Oh, for fuck's sake. Very fast, very fast, very fast, very fast, very fast. That was here, was here. Movie. Yes, this is the technicality behind it. We have this running on surf infrastructure. We can pull camels data directly from camels. We have GitHub, of course, to share all that in. The nice thing is with GitHub Actions, you can make a tooling that automatically generates GitHub pages anytime you do a push. So anytime a student changes something in their thesis, it automatically generates that web page that you were looking at. That is basically the technology behind what I just showed you. There's a few take-homes that I want to share with you. This is the movie for if it didn't work. We should make sure that fair should be easy. If it's hard to do fair, people will not do it. We have to enforce it, but we also have to take away the barriers. There is no excuse anymore for any government that orders a report from Deltares or from anyone else to have just a PDF. That should include the code that run the actual analysis, so they can build on that, and that should be open and transparent. So we have to demand transparent, reproducible deliverables with our science. That was my talk. Sorry for going over time.